Welcome to part 2 of the DevOps Circle. In this session, we'll dive into the practical exercises based on what we learned in part 1. So I think we are all good so far. Let's get to the workshop now. I would like everyone to fork this repo into your own, and we will follow step by step. So I have the repository cloned. So while you are forking the repository into your own, I will be going through some of the files that I discussed earlier in the slides. But before that, let me talk about this project. This is a very simple Flask application that does almost nothing significant, and it's only for the demonstration of DevOps process. This app runs on the port that we specify, and it just does CRUD operations on user's table. We don't need to think much about this application, but we can focus on the Dockerfile. So as I mentioned earlier, a Dockerfile generally starts with the base image that this is going to use. So we are using Python 3.11 image. We can set environment variables in the Dockerfile, and generally we set a working directory. Basically, this is the directory where all the subsequent actions run from inside the Docker container. So this here, it creates a directory called app and CDs into that directory, so that everything that we do happens in the context of that directory. The first step always is to install the dependencies, not of the project, but the dependencies that are required in the system for the project. So basically, I want to let you know that this is a lightweight Ubuntu-like version of the Docker image. So we run the Ubuntu command, and for Postgres we install the lib pqdev, and then we do the cleanup afterwards. Now that we have installed all the dependencies that are required in the system, we can move forward to install the dependencies required for our application. And if you have cloned the repository, then we have this requirement.txt file. And what we do now is we copy requirement.txt file from our host machine. So host machine is where the Docker runs, and Docker runs the container, and container is where where all of this happens. So from the host, that is our local file system, we copy the requirement.txt file into the dot. This means this directory. And after copying that, we install the dependencies from that particular directory using pip install requirement.txt file. And after that, we copy. This is an interesting command to see, copy dot dot. So basically, the first part is for the host, and the second part is for the container. So we are copying everything that's in our host, basically this whole directory, into this app directory, which stands for this dot. Okay, now we specify, okay, we are going to expose the container's 5000 port and map that to the external 5000 port. Actually, wait, not map. We are just going to expose the. Actually, there are a lot of ports in the container, but we only want to expose 5000 port to the host machine. And finally, generally, the Docker file ends with the command that runs our application. In this case, we are using gunicorn. This is for multi-threaded Python applications. It supports multiple requests. What we are doing here is we are running the application on port 500 inside the container, which we have already exposed. Okay, so this might be a bit fast for the Docker file if you are first time looking into the Docker basics. Okay, is once we have defined the Docker file, you remember I mentioned about Docker compose file that allows us to have different containers or multi-container systems, and here is how it looks like. So the Docker compose file starts with the version it uses, and in the services section we define the services that we have. So for our particular application, we have two services. One is the actual web application, and the other is the database. Okay, for database, we are going to use Postgres 15, and we already have uh, Postgres 15 Docker image available in Docker Hub. So whatever we mention here in the image, that is available in Docker Hub, and it automatically pulls it from Docker Hub. We define environment variables here, and since this is just for the local setup, it's fine to define it here. We can also override this from the env file. And for db also, we are going to expose. So this is a important command or statement here. So basically what this means is that the right side stands for the containers port, and the left side stands for the host port. Host is the machine where the container runs. So we are exposing, or we are mapping the internal containers 5432 port to the host external 5432 port. So once we run this and the DB service is up, we are able to access the containers port from by directly accessing the host's 5432 port. Let's look into the web. Notice that we have image here, but we don't have image, but instead build here. That's because we are using custom image for our application, and the custom image is defined by the Dockerfile that we recently talked about. So what this means is that build from this current directory, and it will automatically pick the Docker file that's present in the directory. In Docker Compose, we can also specify the dependencies among the services. So it's true that the web application depends on the database service. So unless the database service is up, um, the web service will not be started. Okay, there are some catches to this, because it's not always the case that even the database service is up, it's ready to accept the connections, but that's a more technical detail we can go into later. And here also we expose containers 5000 port, so it's ready to be mapped to the host port. So we can use any port here. We can just map internal containers 5000 port to say 6000 port here. It doesn't matter, but for the sake of simplicity, it's generally the same. So the port exposed here is now ready to, or available to be exposed in the host, and we do that here. We also specify the environment file from the Docker Compose. It's generally .env, and this is an alternative to env file. So if we want to explicitly define some environment variables in the Compose file itself, we can use this section, but it's generally a good practice to have this as well inside the .env file. So generally, for default setup like this, each service can have access to other service. For example, from inside web, what we can do is, let's say, from inside web we can do, assuming we are inside web, we can do curl, and what is the name of the service? DB, right? So http DB and the port that it exposes 5432, like this. So basically, in the default network config, each service can access other service by their name only. But there are other advanced mode of network where we can modify those behaviors. And the reason we are doing this is actually not for the internal Docker containers to have access, but in order to have access from outside. Well, but in this case, we could also have, like, we could also not be exposing this thing, because the web can directly access DB colon 5432 internally. Let's also have a look at env.sample file. This is a sample file which is generally committed to the repository, and as I mentioned earlier, it defines what are the environment variables that need to be defined. And this is the env file which contains actual credentials or actual like sensitive information if needed in the file. So here we have just defined the database URL and the Flask env variables. Okay, so that's all about Docker and Docker Compose file for this application. Now let's just try and run everything. So what we can do is, what we need to do first is we need to build our application's image. So this is web, right? So what we can do is docker compose builds web. What this does is this reads this section and understands that it needs to read the Docker file and builds an image based on that Docker file. And you should have already cloned the repo, so you must be able to follow me now. Uh, for the first time, this might take a bit longer, but since I had already built this, this is just as fast. So now that we have built the application, we could have also done just Docker compose build, and it would build everything that has this build command. In our case, it's just web, so it will just build the web. It doesn't have to build DB because the DB uses a pre-built image. Now, what we need to do to run our application is just Docker compose up. Okay, so our application is up and running. Let's see if we can access it. Since we um, expose the internal containers port to our host 5000 port, we can access it using http localhost colon 5000. Okay, so it's being connected because it says this is not found. So let's see users. Okay, we haven't done any database migration, but you see the point. So basically, we are able to access our application uh, using the port. Now, in order to stop the application, what we can do is docker compose stop. And I want to experiment one thing. What happens if we do not do this? Let's start our application again. Okay, it's up. Let's see if we can access it. Okay, so previously it returned 404 because that means it can access the server, but the page or the URL endpoint doesn't exist. But here we cannot even access the 5000 port because we haven't exposed it here. Okay. Okay, since we also have some tests defined and PyTest installed, we can also try to run some tests. For that, we just start our application. We can get into the application container by using the command docker compose exec and our service name, web, and the cell that we want to run into, which is class. Okay, we are inside the container now, and what we can do is PyTest. Okay, we only have a single test and it passes. One last piece of thing remains. Now that we have our Dockerfile and Docker Compose set up, now that we can build our own Docker image, it's time for CI and CD. As I mentioned earlier, this CI will be using GitHub, so it exists in the file GitHub slash workflows, where we can define our various actions, and we have only one action here, CI. Okay, this is a bit longer, but I will just quickly go through this. You can also find this in the repository, which you can uh, look into in more detail later. Is the name here, and we define what triggers um, this particular action. It's basically push on the main and master branches and any pull request on main and master branches. So if anyone creates a pull request updating our code, then this will be run by giving some permissions. This is basically to be able to write Docker image to GitHub container registry. If you remember, I mentioned that earlier while talking about Docker Hub and the GitHub container registry as an alternative to Docker Hub. Okay, so we have a couple of jobs here, and it's basically the test job. Here, just like in Dockerfile, we define some services. It's Postgres here, and then we define steps. So this is the standard checkout action. So what we need to do is first we need to check out to the current branch from the repo, and note that everything that we run happens on the root directory of this repo. So from the root directory, we check out to the current branch. That can be either main or master depending on what triggered the action. And then we, as I mentioned about the marketplaces, we this is an example. So this is also from marketplace, and this is also from marketplace. So basically from this, what this action from marketplace allows us is to have Python installed in the CI system. So basically it installs Python 3.11 in the CI. Now that Python is installed, what we can do is install all the dependencies using the pip install requirement.txt command. And earlier we defined Postgres, and it should be up and running, but just in case we wait for the Postgres until it is ready using this command. And anything in run command is basically the bash commands. And if we need to provide multi-line commands, then we can just use this pipe and do the multi-line thing, right? So now that Postgres is ready, we are ready to run our tests. And for test, we provide the database URL, which we provided in the local development using .env file. And then we run pytest.q. One thing to note here is that if any of the step fails, then the whole pipeline or the whole workflow fails, and it will be marked as red cross in the GitHub UI. So basically what happens, what that allows us is that unless the test passes, nothing below this will execute. Basically, if test fail, then we will not be building any Docker image and we will not be pushing any Docker image. So after the test pass, we will build the Docker image. So basically the command is docker build, and dash t is just the tag name or the image name, and dot this stands for this current directory, and it will read the Docker file from this current directory. Okay, now we are using another action for from marketplace. This is basically Docker login action. We need to log into the Docker, and where ghcr.io, and we will have our username, basically the actor that triggered this action, and password. We don't use our plain password, but instead GitHub actually creates a token, unique token, each time this CI is run, and we can fetch it from the secrets. And this is also a good example of not hard coding anything in the code. Now that we have logged into the Docker, it's turn to push the built image into the Docker registry, and this is how we do using this command: Docker push, and the registry name, and um, our user or the organizer name. So that's all about the CI. So now what happens is, let's make some modifications and push it. Okay, so now here we can see this yellow indicates pending, and we can see what's happening here. So it is initializing containers. After this, it will run the actions checkout step, and it's setting up Python using action setup Python that we saw earlier. It waited for Postgres, it's available, and it runs PyTest. All our tests pass, and it goes to building Docker image. Docker image is also being built. Okay, it fails here because okay, the repository name should be lowercase. So since the repository name right now is uppercase, it fails for in that step. But what we can see here is we have successfully logged into Docker. We have successfully built our image, before which we successfully passed all of our tests, and only it came to this step. So um, so if we want our setup to be even advanced, what we can do here is we can also deploy or run commands to push all the images to our AWS infrastructure, and where it will automatically deploy the application. But that's some advanced use case, and depends on the use case as well. So for now, this is all about the workshop on Docker, GitHub, and CI/CD pipeline. I hope this was helpful, and visit careerlink.ai to explore a curated list of powerful AI tools, all designed to meet your specific needs. Dive into our live circles for a deeper, more immersive AI learning experience where you can truly deepen your knowledge and skills. Don't forget to check out our prompt library, a collection of carefully selected prompt books crafted to guide your learning journey. So, what are you waiting for? Start mastering AI today and take your career to new heights. And remember, make sure to subscribe to our channel for more content like this and stay updated.